Okay then, so let's continue with the class. So in this is going to be our seventh session on the same topic. In the previous class, we just covered about the aldol condensation and continue with the reaction. Okay, so we are going to discuss about the naming reaction part only. So in a naming reaction, the next reaction is going to be the Claisen Schmidt reaction there. Okay, so it is going to be the Claisen Schmidt condensation. Okay. So basically, it's a kind of aldol condensation, but what is the difference here? That in this case, we are going to use spacely, like the spatial kind of product simply. Okay, so let's see which kind of spatial product I am saying. Okay, so let's just start that how it is going to work. So basically, it is like a okay, Clayton's chemical condensation is nothing. It's basically like a that is a cross aldol. Okay, let me just make a note. It's behaving like a cross aldol condensation. Okay, so it is basically behaving like a aldol condensation, cross aldol. So let's see what is new about this, like which thing we are going to use like that. Okay. So in this case, like every time the same thing, which kind of substrate we are using, right? That is the thing which we want or which we're going to observe. So which kind of substrate we are using here? That is the substrate. First of all, aromatic. Okay. So in this case, what is the first point there? That we have to use aromatic aldehyde. Okay, and if you're observing something in this case, this aldehyde has no alpha hydrogen, so there is a no alpha hydrogen, and plus that we are using acetone. It's a CH3 CO and a CH3 there, so it's a kind of acetone there. Okay, like this. Okay then. So these two things we're using, that aldehyde which one are not having any kind of alpha hydrogen and substrate. And how about the reagent there? You can use any base, OH negative and base we're using basically. And the temperature sometime like 100 degrees Celsius, not very high temperature. And what we are getting in this case the same product, that is the alpha beta unsaturated, alpha beta unsaturated ketone. Okay, so basically this thing we are getting here, alpha beta unsaturated ketone. So let's just start now that how to proceed or about the general reaction there. So if we are discussing about the general reaction, so how about the general reaction in this case? So basically I am using that let's see, that as we discuss that you have to use aldehyde without any alpha hydrogen, and plus there is a one ketone we are using. Okay, and then base we are using OH, and what is the thing we are getting at the end, that this carbon is combined like double bond, and okay, obviously heat, that the temperature is 100 degrees Celsius, and okay, and this is a CO and CH3 there. So this is the thing which we really are really getting in this case. Okay. Okay, so that's it. Now, how about the mechanism? So the mechanism is like the previous one, aldol condensation one. First of all, there is a enolate formation. So what is the step number one? That you know, for the enolate formation, we are requiring alpha hydrogen. So this is my OH negative, and it is going to abstract this hydrogen. Okay, it is going to abstract this hydrogen. So this O negative ion attack here, and we are getting it's a CH3. Okay, it's a CO, and this is a CH2 negative simply. Okay, means negative charge is generated. The point number one, and you know how it is going to happen. Then this is going to open up, and then basically we are getting it's a CH3 O negative double bond CH2. It means our nucleophile is ready now. So the step number one, formation of enolate ion. Okay, and the step number two, now this is going to take on the benzaldehyde. Okay, so what is the step number two? Let me just write the benzaldehyde be like this, that the nucleophilic attack of this enolate ion. Okay, let me just change the position. Okay, uh, like just for the convenience so that we can attack. Okay, like this. So this double bond attack here, and this bond open up. So what we are getting then, we are getting this is a kind of benzene. Okay, this bond open O and hydrogen, and then this is a CH2 and double bond and a CH3 there. So what is the step number next? That is a protonation. It means it's going to convert in the OH. And after this, when you to heat the product, but we are getting a carbon double bond, right? So that in this case, carbon double bond, oh sorry, this is OH and this is hydrogen and this is connected with the CO and CH3. So basically what we are getting, that this is a double bond and a carbon carbon double bond like this. Okay, so this is that if you're observing with respect to alpha and beta. So it's a alpha beta unsaturated kind of ketone we're getting, right? So this is a product there, that it's alpha beta unsaturated ketone. Okay, so that's it. This is all for the Schmidt reaction there. Okay, so now let's discuss about the second reaction, the reaction number two, mechanism part. I hope it's clear. And okay, welcome to the class. You joined very late. Good evening, everyone. Okay, so right now, till then, I just explained this reaction, that is the Claisen Schmidt reaction condensation there. So which kind of substrate we are using? So basically, it is a kind of, okay, it is a kind of cross aldyl condensation only. Okay, and in this case, which kind of substrate we are using? That aldehyde with zero alpha hydrogen or no alpha hydrogen or any ketone. And the base and alpha beta saturated ketone we are getting, then the same mechanism, that if you're observing, this is a kind of substrate. Okay, this is the substrate part. Like we are using the substrate be like benzaldehyde, and then this is the reaction, general reaction you can say. And then this part is the mechanism below. Like the previous one, the which is going to check the hydrogen, there's an enolate formation and then attack here. And then at the end, when you to hit this, we are end up with this. Okay, so like after aldyl condensation, it's like aldyl condensation, it's not a new. Okay, so let's discuss about the second naming reaction. That is going to be the Perkin's reaction. So like it's important. Okay, actually each and every reaction in carboxylic acid is really very important. So it's a Perkin reaction, or condensation, because we are discussing about the condensation part, right? So reaction there. So now let's just talk about again same, like which actually what which kind of thing we're using. So in this case, if I'm talking about the substrate, so which kind of substrate we are using there. So in this case, the substrate is what? That we are using the aromatic aldehyde, the point number one, that aromatic aldehyde. And yes, for the naming reaction, what is mentioned, and that part is important. And one is the carboxylic acid anhydride. So what is the meaning of carboxylic acid anhydride? It means, for example, this is a CO. Okay, you know the anhydride. What is the meaning of anhydride? This is a CH and this is a CO, and it is connected with one more CO and a COH3 there. So this is a kind of anhydride, that when oxygen group is in between, that is a two kind. Maybe they can be different or they can be same as well. Substrate. And how about the reagent? So like in this case, the reagent we are using basically, that is acid, no acetate, potassium acetate, like the salt of the acetic acid, acetic acid and then put potassium there. So the salt basically we're using. Okay, and which kind of product we are getting? So in this case, the product is the cinnamic acid. It's famous for the formation of cinnamic acid. I will tell you what is the cinnamic acid. So I have to write this, highlight this. So what is the meaning of the cinnamic acid? This is cinnamic acid, aromatic and a carbon, double bond CH. Okay, and this is a COH is there. So it's a cinnamic acid. This is very famous. Cinnamic acid is really, really very much important. Okay, so this is all for the cinnamic acid. Now let's continue that how the reaction is going to proceed. So let's start that substrate we are having. So let's continue with the substrate. The condition number one, if I'm talking about the mechanism, the ditto, the same mechanism like the aldyl condensation. So how about the mechanism in this case, that you will be having um, the previous one, acid part here. So this time, what is the basic criteria? We want acidic hydrogen. So definitely in this case there is a aromatic aldehyde, means that in this case there's a zero alpha hydrogen. So it means in this case there's a no scope, like we are able to extract any kind of hydrogen. But yeah, if I'm using the second one, that is anhydride, so definitely it is possible. So what is the step number one in the mechanism? That the step number one is what? Same formation of phenolate ion like the previous one. Formation of enolate ion. So what is the meaning of this word, formation of enolate ion? you will be having some CH3, and this is a CO, O, CO, and CH3. So, like in this case, we are using a salt CH3, COO negative, and K positive. You know, this is just a counter ion. This one still has a choice. This potassium simply attack here, okay, like this. It means going to abstract the hydrogen. If it is going to abstract the hydrogen, so basically that CH3COH release, right? So what we're getting then, we are end up with CH3, CO, O, CO, and a CH2 there. Again, that this move here, this bond up and up, and there is a enolate formation take place, okay? Because the step is what enolate ion, and this is a double bond, okay? An oxygen still, and the O negative, and a double bond CH2. Now, this step number two is what? This is the step number one, that nucleophilic attack, okay? Nucleophilic. So it's a nucleophilic attack of what? Nucleophilic attack of enolate ion. Okay, so let's see how that again. This is a the benzene we are having. Okay, this is a COH, and then the CH double bond. Okay, O negative oxygen and a CO and CH3 there. So this like double bond simply attack here, and this bond open up. Okay, so let's see on the next slide what we are getting now. So basically in this case we are getting carbon O negative open up, and this is a hydrogen, and this carbon connected one with CO group and O and a C double bond CH3 there. Okay, so this is the point number one. Again, protonation, that this is going to abstract the hydrogen, okay, from that acetic acid. If you don't, you're not getting my point. So let me tell you how. That you know, this is a CH3COOH is there. So from here, it's going to abstract the H positive, and I hope you're getting my point. And then what is the thing we're getting? That it's a OH there. Okay, and please connect the hydrogen CH2 and CH2. And this is a double bond and O COCH3 simply. Okay, then the second third step, that again you have to heat it. When you to heat this again, that the water molecule is going to release, and there is a formation of double bond. So the point number one is achieved. Okay, so let me just simply draw that does a double bond formation take place. This is CH and this is CH there. So double bond is ready. Okay, but since we discuss in this case we are going to get crotonaldehyde, then what is the next step there? That in this case the next step is going to be the hydrolysis step. So what is the meaning of hydrolysis? After the hydrolysis, whatever be the point, okay, this thing, okay, this is going to release. Okay, what is the meaning of hydrolysis? Let me just write that if you're observing, this is the water. Okay, this is the simple water there. So if you're breaking the bond, let me just write the water. Okay, if you're breaking the bond here, so you can see this part is combined with the CO and this part is combined with this. Okay, so this is how we are getting a kind of acid. So let me just draw the final structure here. So if you're observing, the final product is what? The benzene. Okay, carbon double bond CH and a CH, and then this is a CO and OH. This is ready, the thing cinnamic acid, and plus that is a CH3COOH is there, and this is all for the Perkin reaction. So let's just back again: formation of phenolate ion, nucleophilic attack there, and then heating, okay, or you can say the hydrolysis step, and after heating or hydrolysis we are getting this, and further if you undergo the hydrolysis more there, so the ester is going to convert into the acid there. Okay, that's it. Very good evening Dashika, very good evening Shiva. Ester formation, how much complete till now? So you can say almost three reaction, okay, not two reaction. One is the Claisen Schmidt reaction, this is the second one. Very good evening Niharika, and very good evening Dashika. And please, it's a request to everyone. If you want that I to continue the classes, please join on a time, okay? Otherwise, I'm not going to take the classes. Okay, it's just a request. I'm using my time, at least you to join, okay? If you don't want to continue, not an issue, I can stop, okay? That's it. So this is all for the Perkin reaction. If any point not clear, let me know. Okay, so let's discuss about the third reaction there. That is the after the Perkin reaction, the next reaction is going to be the That is the Claisen condensation. But before that, let's solve a question, okay? I guess so much information. And one more thing, like the sort trick, every time mechanism we are not going to discuss. So let's discuss about the sort trick there. So what is the sort trick for the Perkins reaction is there that this is the carbon and a double bond. Okay, this is benzaldehyde, and this is how hydrogen, CO, O, CO, and a CH3 there. Okay, so basically that this is how they combine. Okay, and what is happening? The water molecule simply remove there, and once the water molecule remove, what we're getting, that is a kind of ester, but still ester undergo hydrolysis because we want final product as a acid. So, like CH, CH, and a CO, and O, and a CO, and CH3. Okay, and then again, when you have to undergo hydrolysis further, so the final product we are getting the same, that the cinnamoldehyde, sorry, the cinnamic acid, and this is a CO and OH. This is the final product, and we are getting CH3, CO, and OH. Okay, that's it. You didn't 7 p.m. Okay, Dashika, because I guess me I was your chat, okay? So like actually today I just started class at the 6:55 something, okay? Because I have to wrap up more reactions, so that's why. Because after today I'm going to take the next class from Monday. Actually, I am busy with my exam. My exam is going on, that's why, okay? So let's continue. This is all for the Perkin reaction. Now let's talk about the next one. That is the Claisen condensation. It is very interesting one, that Claisen condensation. Okay, so what is the meaning of this Claisen condensation? In this case, what is the very much important point? In this case, the carbonyl group. Remember that is the aldyl condensation. There we discuss about the carbonyl group. Okay, have at least one alpha hydrogen. But in this case, what is the key point? That is the carbonyl group with no alpha hydrogen. So it means that is it's a fix there. Claisen condensation, carbonyl group without any alpha hydrogen. This is the point number one. Okay. What is the second point there? Like if you to compare with the aldyl condensation, they were using diluted NaOH. But in this case, we are going to use the concentrated NaOH. And if we're talking about the product there, so in this case, that is the product is what? Acid plus alcohol simultaneously. Okay, so this is a little bit important reaction because it's a kind of different type of reaction. Wait, I use Claisen condensation, right? That's not Claisen. It's a Cannizzaro reaction. Okay, wait. I'm sorry. Okay, it's a Cannizzaro reaction. So basically, it's a Cannizzaro reaction. So let's see. That is some important point. In this case, it's a kind of redox reaction. No, it's not a redox reaction. That is the disproportionation reaction. This is better to use. That is disproportionation reaction. Now, can you just tell me what is the meaning of proportionation reaction? Disproportionation reaction? The reaction in which the same thing undergo oxidation and the reduction as well. Okay, so if you want to consider the previous classes, so you know that every time if I'm having a chlorine is in zero oxidation state, so it's going to convert into the Cl negative or a Cl positive. Disproportionation. It means the same thing undergo oxidation as well as the reduction there. Okay, so as we already discussed, in this case we are going to use a carbonyl group without any alpha hydrogen. Okay, so let's see how that this is a CHO. First, try to understand the reaction, then mechanism is easy there. This is CHO and this is a CHO, okay? So we are using two molecule. So basically what is happening, this one, okay? Let's suppose this is going to convert into the acid. So the same, okay? Actually we're using a mol. I'm just explaining only, that's why I'm not using differently, okay? So look at this. In this case, the second point is what? That is HCH2 and OH is there. So this is how the case that the same group undergo oxidation as well as reduction there. So if you're observing, let me just highlight this point. If you to observe this point only, so it's a oxidation, addition of oxygen there. But on the other hand, if you're to converting aldehyde into the alcohol, so it's a reductive part. So the same formaldehyde converted to the acid as well as into the alcohol as well. Okay, so it's a kind of reduction there. Okay, then. So now let's see more example. Okay, so let's better to clear the concept. Let's consider one more example. What if that I'm using benzaldehyde, but in this case there's a one very much important key point that we can't use any aldehyde or ketone with alpha hydrogen. So same here, like again, just for understanding purpose, I'm writing the molecule different, otherwise it's the same thing. Okay, so again, that is the first product. We are getting a acid, that is a benzoic acid, and one is this, that is a benzyl alcohol. So this is how same thing. Okay, first of all, I hope this point is clear that what is the Cannizzaro reaction. But like, how about the mechanism? The mechanism is also very much important here. So let's discuss about the mechanism of the Cannizzaro. So it's a little bit different mechanism from the as compared to the previous reactions. Okay. So let's just talk about the mechanism part. So in this case, how about the mechanism? Again, for every reaction, like this is really much important. Cannizzaro, what we are going to start, like reagent and then product, and then after this let's discuss about the mechanism part here. So in this case, the point number one, we are using acid, and let's suppose this is our formic acid, formaldehyde again, and this is OH there. So right now in the previous cases, what is happening, there's a some base come and then abstract the hydrogen, but in this case OH has only one scope. What is that one scope? That this OH simply attack here and this bond open up. Okay, like this is the only way, because in this case there is a no acidic hydrogen, so that OH is going to abstract. So that better OH being like no, not an issue, I can being like a nucleophile there. So after this, that if I have to read the step there, so it's a nucleophilic attack. It's a nucleophilic attack. Nucleophilic attack of hydroxide ion. Hydroxide you can use simply. Okay, and then what we're getting, that is O, CO negative and hydrogen and then OH. So this is the first point is ready. Okay, so this is my intermediate number one. Okay, in this case there is a two kind of intermediate we are getting. So what is the meaning of this word? That is a intermediate one. Okay, so in this case this is known as a uh, monoanion, or the only one anion, mono anion. Okay, let's just use the one. So it's a mono anion. I will tell you, like, I'm using this word mono anion. So this is the point number one. It's an intermediate. Okay, intermediate number one, simply the OH attack here, bond open up, and that's it. We're getting an intermediate number one. And now what is happening? That in this case, again the base come right. That is a base has a scope. So this is the point number one. Again the base come. Okay. Now it's a reversible reaction first of all. It's reversible. So OH again come. Now OH will like where I have to restrict the hydrogen. First of all, OH attack on the CO bond like nucleophilic attack. Now OH again come. So this time that there's a no scope for the nucleophilic attack. So OH will like, why not? I can abstract your hydrogen OH. Right? So in this case, what is happening? This OH simply abstract this hydrogen from here, and this is how the bond open. Okay? Means what we are getting, this is a H and a O negative, O negative and hydrogen. This is intermediate number 2. Yes, here intermediate play important role. So this is my intermediate number 2. Because do you know how the question asks that during the Cannizzaro reaction, which intermediate is going to proceed? Like the dianion or monoanion there. So in this case, this is my intermediate 2. And if you're observing, on the oxygen there is a two time negative charge, so I can use, that is, this is nothing, this is my dianion. Di means two, anion means two time, like there's a O negative and O negative. So the first point is sorted. Okay, so that is point number one, simple nucleophile attack, and that's it. Why I'm using so much time for this mechanism? Because it's little bit important. Okay, so this thing is ready now. Let's move to the next slide. Okay, after this, once we are ready, now this is HCO and O negative and hydrogen. Second, now our thing is ready. Now the second one is what? HCO and hydrogen there. So in this case, let's see what is going to happen. This simply attack here. Okay, this hydrogen attack here, and this bond open up. Okay, and this is known as a hydride transfer. Hydride transfer. Like if you're observing, that is a hydride is transferring from one molecule to the another molecule. So then what is happening? It's become CO and hydrogen and O negative. This is sorted, right? That the first point we're getting, this is a COO negative and potassium, the salt. As we discussed, one is going to be oxidized and reduced, and most of the time we are getting a salt. Better to rate the salt, okay, like this Cu negative and K positive, or if you're using NaOH, so it's become Na there. So the salt or acid, okay, you know very well that after further reaction that it's going to convert in the acid there. So the first part is sorted. Okay, first thing is ready, that acid. Now we are just left with only this thing. Okay, when it's going to attack here, what is happening? So in this case, the second point that this is O. Okay, now I am talking about this molecule. Okay, this is a CO and O negative, hydrogen and hydrogen. Okay, and wait, this molecule become this. Okay, so that's it. This is how we are end up. And further, that do you know that hydride transfer? This is really, really much important. Let me just write here, okay, because it's important. The step name, the step number two, hydride transfer. Okay, and one more thing. It's a RDS step. It's a slow step. It's a redetermining step. Okay. And after this, the next step is what? Protonation again. Okay. You know, we are just left with only one proton. So the protonation take place. So it's become H and a COH and H and this. So this thing is ready. Your product is ready. The point number one, this is known as a Cannizzaro reaction. Okay, this is known as a Cannizzaro reaction. Now your time, any problem with the mechanism, please let me know. I know that mechanism you have to remember, right? But try to understand. First of all, which attack, then one anion generated, the second one, then again there is a transfer of hydrogen. So this is the point number one. And so I write it's a simple Cannizzaro. Okay, like same molecule we are using. So better to write here that it's nothing. It's a simple Cannizzaro. Okay, because like the aldol we are going to discuss about now, cross Cannizzaro as well, or intramolecular Cannizzaro. So this is so simple Cannizzaro reaction. I'm using simple word. Okay, now let's talk about the next one, that is cross Cannizzaro. So one thing, recall, Cannizzaro means aldehyde or ketone. Aldehyde because ketone have no scope, that's zero alpha hydrogen. So aldehyde with zero alpha hydrogen, and cross means different. So in the previous one, like both are the formaldehyde or both are the benzaldehyde. What if that, if let's suppose, okay, let me just write in the top. That is, let's talk about the cross Cannizzaro. So what does the meaning of this word? That is a cross Cannizzaro reaction. That in this case, I'm using two different molecules. So the molecule number one, it's a COH, that is a benzaldehyde, and the second one, that is, this is a formaldehyde. Okay, so the same thing, one is undergo the oxidation and one is undergo the reduction there. Basically, you can say. But you know, when the cross Cannizzaro came into the picture, so like which one is really going to participate? This is also the important part. Okay, wait. So like the question be like the point number one, the product number one. Maybe it undergo oxidation or it undergo reduction. Or the point number two, that is maybe Okay, so the point be like, so do you to go with this method or this method? So for this one, let's discuss more about the Cannizzaro. Wait, wait a second. Okay. Okay. So now let's write a knot. That what is the knot? The compound. Okay. Like how to decide the benzaldehyde or which. So the compound that is more reactive means the compound which is more reactive toward nucleophilic nucleophilic addition reaction undergo oxidation and other undergo reduction. Okay, so this is the simple one. Oxidation more reactive. Okay, another one is the like reduction part there. So this is how you can decide. So in this case means what is the main point? Like you will be having benzene and you will be having this. So can you just tell me if nucleophile wants to attack, so where the nucleophile prefer to attack? Like this is A or this is B. According to you, which one is the feasible attack here? Yes, please answer the question that we discuss about that you have to consider the part where nucleophile easily attack or more reactive. That part undergo oxidation there. So like so do you have to go with the first one or so do you have to go with the second one? Okay then so listen that in this case we have to go with the this. Okay, why? Because in this case look at this is a common thing in both the cases, but if in this case nucleophile is going to attack, so you know the benzene ring is provided a kind of hindrance, but hydrogen will be like I'm very teeny tiny thing, so better to connect with me. So it means that in this case nucleophile prefer to attack on this. Okay, here. So what will be the final product of the reaction there? The final product of the reaction is this. Is this is the correct one? No, it's not the correct one because the nucleophile attack where first that part is undergo the oxidation there. You can observe this. Like if let's just suppose you're observing the blue one where the nucleophile attack, the OH group attack, so it's become as acid, and the yellow one that is behaving like electrophile here, that simply it's undergo the reduction there. Okay, I hope the point is clear. What is cross Cannizzaro? If you want to observe the mechanism, same ditto. Okay, so like cross Cannizzaro mechanisms, same there. Now let's talk about the last one, that is the intramolecular Cannizzaro. So what is the meaning of this word? That is intramolecular Cannizzaro, like in the same molecule. Like after aldol, the same that cross, then the intramolecular. So same here. So in this case, let's just use this molecule. Okay, I'm explaining this on the next slide. But if this is the molecule we are getting, so every time search for different kind of aldehyde without any alpha hydrogen. So this is the point number one. Again, in this case, if I'm using concentrated NaOH, okay, so okay, you will tell me. Okay, like what is the final product? I want to check like you are getting my point or not. It's not possible, right? Technically. So anyway, that. So in this case, that obviously the OH is going to form here, and the terminal one become the acid there. So this is the final product we are getting, right? Simple. And salt, right? K negative, O negative, and Na positive. So this is the point number one. Now the second point, that how to proceed with the mechanism, right? So everyone, when we're discussing with the mechanism, now we're a little bit familiar with the mechanism. So just try to observe like how the mechanism look like. Anyway, although I have to explain that how the mechanism there, that you will be having the benzaldehyde, same thing, CO, CO and H. So first of all, OH may be attack here or OH may be attack here. But where we to attack, that the same here where the point where that the possibility of the attack is simple. So in this case, if you're observing, if OH attack here, so benzene be like hindrance. But if it attack here, so this group be like not an issue, a very small group. Right? So in this case, that you can say which attack on the CO group first. Okay. So that what is the second point? This is a OH and this is a CO. Okay, it's a O negative and a OH and hydrogen there. So what is the step number two? If you remember that again OH come into the picture, abstract this hydrogen. So what we're getting then? Benzene, CO and O negative and hydrogen. Next step is what? Hydrate transfer. H transfer, or let's see the hydrate transfer. So what is happening after the hydrate transfer there? That this hydrogen simply transfer here, this bond break like this, and this is a O negative hydrogen and double bond O negative. And since Na there, Na connected here, next step is what? The protonation again. Once protonated, this is the final product. This is how you can go with the mechanism. This is all for the cross Cannizzaro. Let me just quickly brief you the Cannizzaro, that you have to use any aldehyde without zero alpha hydrogen. Okay, this is the point number one. Second of what we discuss about normal simple Cannizzaro, then cross when we're using two different molecule, or which one undergo oxidation first, where the nucleophile attack more or easy to attack, and the second one is undergo the reduction there. If inside the same molecule both aldehyde is connected this, it's become that intramolecular Cannizzaro. This is all for the Cannizzaro reaction. Okay, I hope it is clear for you. Just observe this. If still any problem you are having, please let me know. Okay, so this is all for the Cannizzaro reaction. Now let's discuss the next one, right? So the next one, what we were discussing after the Cannizzaro. Okay, now let's talk about the Claisen condensation, right? So the Claisen Schmidt is a different one, and Claisen condensation is a different one. Okay, in the previous one, we're using benzaldehyde plus ketone, and this is a different reaction. Be noted, it looks similar maybe, but it's a different one. It's a Claisen condensation only. So what is Claisen condensation? That in this case, the substrate, which kind of substrate we're using? So in this case, the substrate is ester. We are going to start with the ester there. How about the reagent? We are using the reagent is what? RO negative. It means strong base. Strong base. Don't worry, when we read the general mechanism, it will be very clear for you. What is the final product? We are getting beta keto ester. Okay. So, like how? What is Claisen condensation there basically? So let me just write the general reaction for you. So what is the general reaction? That let's start. We are requiring ketone. Sorry, ester. So it's a ester there. It's a CH2, CH3. And in this case, we're using any base, CH3, CH2, and O negative. It's a very strong base, the step number one. And the step number two, the same hydrolysis one. And it's become CH3, CH2, and a CO, CH. Don't worry, I will change the position of my video, okay? CO and O. And this is a CH2 and CH3. Okay, see this. I hope it's visible. If not visible, don't worry. We will discuss about the mechanism as well. So, important part is what we are just starting with ester, and at the end, like what is written here, the product, right? Let me just highlight out the product. So, like with respect to this, this is alpha position, this is beta position. So, it's become beta beta ketone group and it's become ester. So beta keto ester is the product we are getting. So now let's talk about the mechanism again. Okay, how about the mechanism? So same ditto, the first one, what that is a formation of enolate ion. So like same repeated mechanism again, formation of enolate ion. So how about the formation of enolate ion? This is CH3, this is CH2, this is CO and O, CH2 and CH3, right? And next, this is CH2, CH3 and O negative. Okay, so next step is what? That this is the only acidic hydrogen. This is the only acidic hydrogen. So it means this is going to abstract this hydrogen. Yes. So let's see how to write. This is a CH and this is one more CH and this group is simply attack here. Okay, abstract this hydrogen like this. And then what we're getting, it is a CH3, CH negative charge generated. And this is a CO and O, CH2 and CH3. And next step, you know, that is this is how it's become enolate. So next step is what? It's a CH3, CH2 double bond, CO negative, O, CH2 and CH3. That's it. We are ready with the enolate ion. Second step, that is the nucleophilic attack of the enolate. Same ditto, okay? That is the nucleophilic attack of enolate ion. So in this case, that is you will be having enolate and it's going to attack. So let's see how. Again, it is a CH3. This is CO and oh sorry, there's a 2 CH. It is a CH2 and CH3, then O, CH2 and CH3. Our enolate is ready. So let me just write this be like this is a CH3, you know, and CO, O, CH2 and CH3. So this group, okay, this group, oh sorry, then it is a negatively charged. So it's attack here, this bond simply attack here, and this bond open up. Okay, so let's see what is going to happen. It is a CH3, it is a CH2 and O negative. Okay, this is, let me just write the group down, okay? Like O, CH2 and CH3 because that is the lengthy chain, okay? And this is a CH, CH3 double bond O, CH3. Wait, maybe it's look very glittery for you. Let me highlight this group, okay? This and this one, this, okay? That's it. Now, next step is what? The removal of the living group. Okay, the third step is what? Removal. Although I just explained to you here only that in this case this O negative attack here, and you know that this is a very good living group. Ester is a very good living group. So once this group leave, so what we are getting that this the same thing, CH2, CH3 and O negative release, and then CH3, CH2 double bond O, and this is CH3, CO and O, CH2, CH3. It's a CH2 and CH3. This is how we're getting a product. Wait, I have to change the video. Okay, I hope it's visible now for everyone. So just first of all observe, take your time. Okay, then we will continue. And you can write that is this is step number 3, removal of living group. Removal of living group. Okay, this is all for the Claisen condensation. Claisen Schmidt is a different, Claisen condensation is a different reaction. Now let's see the next reaction, that is Dieckmann reaction. Okay, Wait, I have to change again. Now let's see the next reaction. It is going to be it's the Dieckmann. So what is the meaning of the Dieckmann cyclization? That in this case, see, right now what we're doing, in the very first, that is a Claisen Schmidt, where there we're using aldehyde or that one ketone. The next one, we discuss with the Perkins one. There we're using that one is ester and one is acid. So from the ester, we're getting a cinnamic acid. But next one, okay, that we just discussed, Claisen, there we're using ester and we're getting beta ketoester. But what if both the ester present in a same group? Right? Means maybe you're not getting. Wait, I will explain. So in this case, this is a Dieckmann cyclization. Okay. So in this case, let's just first write the same thing like substrate and all this thing. Substrate is the diester. In this case, we have to use the diester. The step number two, the reagent. So how about the reagent? Reagent is going to be the R negative, or again, that is a very good, very much strong base. And how about the product we're getting? It's a beta keto ester. Okay, beta ketoester. Don't worry, again we're going to discuss about the mechanism. If you have to observe again, what is it? Beta ketoester. And what is it? It's a beta ketoester. Do you know that this Dieckmann reaction is actually the updated version of the previous reaction? Yes, it's like that intramolecular Claisen condensation. Now let's start that how to proceed, or what is the general reaction here. So in this case, generally, that it's a CH2, CH2, and this is CH2, CH2. And some of you like, ma'am, you see, we can change the number of carbon. Yes, you can, but then the ring size is going to affect. You know, the five member is very much stable, so that's why we are using a five member. Otherwise, like you can use any number of carbon. So in this case, let's just count one carbon, two carbon, three carbon, four carbon, five carbon, six carbon. So it's a 1,6 diester, right? Like at one position, six position, there's a ester group is connected. So it's a 1,6 diester. And what we're using again, that is this is a base CH3 CO negative, the point number one. And the second one, HCl we're using just for hydrolysis purpose only. And what is the final product? I know after the product you'll be like, ma'am, what is this? But don't worry, we are going to discuss the mechanism. It's a OCH3 group. Okay, so it's a OC3 group and a double bond. Now let's see that with respect to this carbon, it's a alpha, this is a beta. So it's a beta keto ester. So it's what? That is, it's a beta keto ester there. Now let's talk about the mechanism of the same reaction, like how to do the mechanism. Again, just try to understand that actually how to approach the mechanism, right? So anyway, let me explain this. This is a CH2, this is a CH2, this is connected with one more CH2, and like this is a symmetric group, so you can take any group, it's totally your choice, right? So it's a CH2 and this is a CO and OCH3 there. So in this case, like again, first of all, you will be using a kind of base that is RO negative. So it's going to abstract any hydrogen. You can connect, use any hydrogen. Okay, both are symmetric. You can go with this hydrogen as well or this hydrogen as well. Let's see, this OH RO is going to attack on this hydrogen basically, let's say. So this is my H group, this is my hydrogen. O simply attack here, this bond open up. The two same thing. This is a CH2 and negative charge generated, it's a CO and a CO CH3 simply. And this is a CH2 and this is a CH2 CO and OCH3. Now you can form enolate ion, okay, or like simply attack the O negative. So this O negative group, this O negative charge attack here. Okay, like you can form enolate, it's totally your choice. And for these kind of question, better to give some number. So let's use some numbering. Like how about the numbering? So let's just write it's a carbon number one, carbon number two, carbon number three, carbon number four, and a carbon number five. So one thing is sure that I'm going to get a five member ring. Okay, not an issue, five member ring. And now let's start with the numbering that it's a one carbon, two carbon, three carbon, four carbon, and five carbon. At the first carbon, look at this. This group is connected, right? It's a CO, OCH3. This group is connected. And if you have to observe the fifth carbon, Look at this fifth carbon, okay? So in this case, what we are getting now, that is for the fifth carbon. Fifth carbon is connected with this is CO negative, okay? And this is OCH3 there. Oh, sorry, O negative, right? Connected it directly. And next one is what? OCH3 there. Next step again, that O negative going to revert back. It means this O negative simply attack here and this OCH3 group release. Be noted whenever you are having OCH3 group, so it's going to release. Okay, so what is the final step? That it's a double bond and a CO OCH3 and double bond generated. This is all for the Dieckmann reaction. Okay, now Uh, of course, Dashika, okay, that for the board exam, you know, naming reaction, if we are talking, the first chapter, not very important, but for the board exam as well, this chapter is really very much important. Every naming reaction. Okay, just be noted, just make a sequence. Aldol condensation, and then Claisen Schmidt, and then the Perkin one, and then this, what is the name, Claisen reaction, and then Dieckmann, and then Cannizzaro. Everything is ditto. Like if you're observing what we are doing every time, extracting a hydrogen base, then enolate formation, then attack, then bond open up, and then hydrolysis. That's the same thing we are doing again and again. Okay, so this is how we are getting L beta keto ester. Okay, so I guess it's fifth naming reaction. Okay, now let's see the next. That is benzoin condensation. I know so many naming reaction, but of course they are important. So let's see. The next one is what? That is benzoin condensation. So what is the meaning of this word? That benzoin condensation. Or let's see, first of all, let's record what is this benzoin, right? So let's discuss about the benzoin condensation. Okay. So let's just write the same mind map. That is who is going to react? Substrate. So in this case, substrate is what? Aromatic aldehyde. Same. Okay, this aromatic aldehyde where we are going to start. Second one, that is reagent. Reagent, which kind of reagent we are going to use? That is alcoholic cation. Okay, what is the final product here? That is benzoin. But like main point is what is this benzoin? Let's discuss about the general reaction, then it will be very clear for you. So let's talk about the general reaction. So how about the general reaction? That you to start with a kind of benzene. Again, these kind of reaction is not very clear without mechanism. So this one we are using, you have to use a kind of nucleophile cation, and then this is a CO connected with one C which is there, and this thing is known as a benzoin. This thing is known as a benzoin. And if we are observing the name, like the name is what? The numbering is starting from this carbon, 1 and 2 carbon, right? IUPAC name I'm saying. So the name for this compound is what? At 2 position, the hydroxy group. Because that is not the principal one. This is the principal one. So it's become 2 hydroxy and then 1 2 diphenyl. That one phenyl this and the second phenyl this. So it's a 1 2 diphenyl. So 1 2 diphenyl, and then how about the number of carbon? There's a 2 carbon. So it's become ethane, right? Ethanone. Why ethanone is there? Because obviously the ketone is the main group here. So 2 hydroxy, 1 2 diphenyl, and ethanone. So this is the nomenclature of the compound as well. Otherwise, this is normally the benzoin. Now again, mechanism, right? Mechanism is important here. So let's discuss about the mechanism part, like how the reaction is going to proceed. Okay, so just think about it. Actually, what we are going to observe. Look at this is a CO there, okay, and K positive and Cn negative, definitely it is being like a nucleophile. So the only choice, the casein is going to attack, then and then it's behaving like the nucleophile there. Step number one, casein attack here, and then what we are getting there, it's a benzene, this bond, okay, I'm sorry. This is how the bond open up, this, and this. And this is a O negative. And the CN is there and hydrogen. This is the first thing we are getting. Now the second point is what? Hydride transfer. Okay, so after this, what is the second point? That is hydride transfer. So what is the meaning of this word hydride transfer? Hydrogen is going to transfer there where you're observing the hydrogen, that this hydrogen. So it's a hydride transfer. So let's see actually what is happening. This O negative abstract the hydrogen, and let's see how. If you to observe, this OH is there, and this is my CN group there. Now, negative charge generated. So what is it? It's nothing. It's nucleophile. So basically, nucleophile and the same nucleophilic, like nucleophile and electrophile kind of reaction. Yes. So this is ready. Now one more second step is what? After this thing is ready now. So this is a OH and this is a CN negative charge. One more benzene, right? Let me just write the COH be like this. So this simply attack here, this bond open up. So OH group, and this is a CN, O negative, and hydrogen. Again, what is happening? Hydride transfer. Okay, because CN is a better living group as well. So again, there is a hydride transfer. So what? That this oxygen abstract the hydrogen from there to there. Okay, I'm just simply changing the position. Okay, so this is the hydrogen now. The next step is what? Removal of the group, leaving group, removal of the leaving group. So what is happening? This is O negative. This will like CN. It's enough. Now you have to leave. So what is happening then? That is the final product we are getting here. This is C double bond O, and this is a COH, and this is hydrogen. I hope now it's clear. It's become the same 2 hydroxy diphenyl and ethanol is there. See, this is the final product, the benzyne B font there. This is all for the benzoin condensation. Okay, so let me just check any more naming reaction left, because my main is in the like I have to complete all the naming reaction. Yes, that's it. This is all for the naming reaction. I guess so much time. Now, please let me know any problem with the naming reaction. So, listen, my point. I know naming reaction. I know there's so many mechanism. But listen, this is the only chapter where we are going to cover the mechanism part. And it's not like a rocket science. Every mechanism is same. Nucleophile attack and then nucleophile generated attack on electrophile, and then something is going to live. There is a one common thing. The last one, either the protonation or the leaving group. When ester or CN leave, okay, or let's suppose if there is a some kind of OH is there, so hydrolysis. Okay, so better to make a kind of list of all the name reaction sequence. Aldol followed by the Claisen Schmidt reaction, and then followed by the next one, that is Perkin reaction, then followed by the Claisen condensation, then Dieckmann reaction, then Cannizzaro, and then this benzoin. That's it. Okay, now we're just left with only one more electrophilic reaction there. Okay, so better to cover quickly. Okay, last one, and after this, let's end the class. So like the same thing, if I'm using this word electrophilic substitution reaction, you already know. The last one is what? Electrophilic substitution reaction. So what is the meaning of this word electrophilic substitution reaction? That if let's suppose there is a COH group, okay, I'm using a kind of electrophile. So then what is happening? It is a meta-directing group. Okay, minus M group. So the electrophile is going to connect only one position, means that is the meta one. Okay, this is E. It can be uh, hallucination, it can be bromination, iodination, sulfonation there, or nitration as well. But it can't be Friedel-Crafts alkylation and or acylation. Can you just tell me why? Why not Friedel-Crafts reaction? Means that what I want to highlight here, that if in this case I'm using this RCOCl and there is a kind of AlCl3, or that is R X. So, alkylation and acylation. So, what is happening? That COHS group is still connected and 1, 2, and 3, okay, meta position. It means this is going to connect here. But do you know the Friedel-Crafts alkylation or acylation is not visible here? Friedel-Crafts reaction is not visible here. Can you just tell me why? Remember the limitation of the Friedel-Crafts, okay? Since this is a Lewis acid. Yes, although you're right acid, but this is a highly deactivating group. Recall the limitation of the Friedel-Crafts reaction that nitrobenzene never ever give the reaction positive. Why? Because benzene is a very deactivating group. Same that in this case, the CH is also a very deactivating group, so it can't give the reaction. Okay, very minor, so better to say no. Now, if I'm writing the order, okay, order of the reaction. So like right now we're discussing about all the carbonyl, right? So how about the order there? Let me just write the order. That reactivity of acyl compound means, for example, if you are given with the rCl group and all this thing, then who is going to react first? So reactivity toward reactivity relative, sorry, relative reactivity of acyl compound. So first of all, let's suppose in a question you are given with acid chloride, so it's react first. And one more, make a note. That is for nucleophilic attack. Nucleophilic, not electrophilic. So this is more electron deficient, followed by anhydride. This is the next electron deficient group. And then RCOR is there. And then followed by that RCONH2. Let me just explain why quickly, okay? So in this case, like the common point, this is a common, and common. Like this is the common thing. It means the Cl group or the OR group, these group is going to affect the molecule, right? So in this case, first of all, this is a very good minus I group, and halogen family is famous for their minus I effect dominancy, right? So it is going to abstract the more kind of electron density. So it's basically electron deficient. If it is electron deficient, so definitely nucleophile is going to attack here. The point number one. Okay, then cool. But in this case, if you're observing, oxygen has a lone pair. Like if you to compare between this and this, that chlorine, I know chlorine has a lone pair, but you know very well that minus I effect of the chlorine is dominating over the plus M effect. So oxygen is there, cool then. So it means this is out of the race now. So now we are observing that both like the anhydride and ester has a oxygen has a lone pair. Okay. And in this case, the nitrogen also has a lone pair. So now let's compare that why the NH2 group at the very end. So NH2 be like, I'm less electron less electronegative. So I have to give electron first. So you can say that is a NH2 is a better donor over the OH group. We know this thing, right? Donation tendency. So it means donor means this gives already gives so much electron. So this carbon like I'm not electron deficient because I'm having NH2. NH2 has a lone pair. I can handle the situation. Okay then. So that's why at the very end, yes. But now the important point is what that why between this and this that unhided first and this later. Okay. So now there is a common point. This oxygen and this group. See this group. Okay. Can you just tell me which kind of group this is? Electron donating or electron withdrawing? Yes, please. Yes, Shiva. Yes, please. That in case of unhydride, it is being like electron withdrawing group or electron donating group. Yes, please. I guess it's an easy question. Between unhydride and ester, which one is behaving like electron withdrawing group or electron donating group? Okay then, so listen my point that this is a OCR group. So this one has a minus I effect. as well as uh, wait, it is behaving like a minus I effect as well as what? So let me just write minus I as well as minus m, right? See your group. But it's behaving like, okay, it's a minus I, but plus m, right? So it means this is a better donor. It is a good donor as compared to this. So means overall, we have to consider that it's a electron withdrawing group. And it is like 50-50. So it is a better donor, yes. So better donor means less electron nucleophilic center, yes. And hence this is the order here. So the point number one, an acyl chloride, chlorine is minus I. And the second one, that oxygen still has a lone pair, but does a like the electron donate withdrawing concept of the CUR group. And in this case, this lone pair, but plus some effect is also present there. So not very good acceptor there. So that's why in this case we are observing the trend. Okay. Yes. You're right, Shiva. Okay, I hope this point is clear or this order is clear for you. And that's it. This is all for the today's class. Okay, and next class will be on next Monday, and after that, I'm going to take the classes continuously. If you have to join, okay. If you don't want to continue, let me know. Okay, I'm not going to take the classes, but it's a request. Please join the classes then. If you want, I have to continue. Okay. Thank you then. This is all from my side. Anything you want to add or you want to ask, please let me know. And again, make a notebook, revise the naming direction continuously, very much important, not only for the J, but as well as the board exam. Board exam 75 criteria, and you know very well that NTA right now changed all the most of the different old kind of notification. Now you're able to give 3 time advance, and that that optional criteria is not there. 25 question. Okay, so better be ready. Thing is not going to be that much easy. Okay. Thank you then. Thank you so much for joining the class. Thank you and have a nice day. Thank you so much.